Now let's take those three terms that we just defined, HP, HF, and HT, plug them back into the energy equation. So pressure at 1 over gamma plus V1 squared over 2G plus Z1 plus the head of the pump is going to be equal to everything coming out of the system. P2 over gamma plus V2 squared over 2G plus Z2 plus the head of the turbine plus the frictional losses. Now typically we'll rearrange this to be the energy of the fluid coming in. So let's do that now. So P over gamma plus V squared over 2G plus Z coming in equals, it's going to have to be all that stuff coming out plus Z out plus the head of the turbine minus the head of the pump plus the head of friction. And remember, head of the turbine is going to be the work that we put into the turbine. So we can just call that the power of the turbine divided by rho GQ. The head of the pump will be the power of the pump divided by rho GQ. HF we're going to talk about because we're going to deal with that equation a lot of different ways. So I know students like their boxes, so there's the box. Those are the really important equations. Also, the reason this is in and out, this makes it a little bit simpler. So if you have a piping system that's got 2 inputs and 1 output, or 1 input and 3 outputs, you are able to use this equation because you can just sum up all the different ones. This is also where Bernoulli's equation would become useful. If you know what the pressures are, you can figure out how much is going through each part. But that is the end of our energy equation. So we're going to be using this equation quite a bit. Now we have to remember, there's 3 assumptions to use this, because of the way that we put it together. We have to assume a steady flow. If we don't assume a steady flow, this doesn't work. We have to assume a constant temperature flow. Because if it's not constant temperature, then we have to start worrying about Q coming in and also internal energy in the fluid. And the last thing we have to assume is incompressible. Because if it's not an incompressible flow, we've got other things going on that we have to take care of. So 1, 2, and 3. Those are the 3 assumptions that we need for this. Now notice these are slightly different than the assumptions that we make for conservation of mass, conservation of linear momentum equations.